Hello everyone and welcome to Network Talk. This is Sundar. Today we are going to talk about networking fundamental, the important topic of OSI layers. Today agenda is OSI layer history, OSI layer model, brief explanation of each layers. So let's jump into the topic. In earlier stage we have multiple operating systems. Okay, Linux, Mac and then Windows. So each device need to share the data to each operating system, and the time each operating system using different kind of method to transmit the data to different communicating to the devices. So we need the solution to each operating system need to follow some standard organization rule to communicating transferring data to one operating system to another or same operating system itself. So that OSI is developed by International Organization for Standardization in 1974. It contains 7 layers. Each layer has a different function, but it's a specific processing function. OSI means Open System Interconnect Model. It has 7 layers. Seventh layer is application layer. It's like a user using the application like Chrome browsers or mail server. Presentation layer. Its presentation layer is the controlling our JPEG image. Like if you are opening on browser, that browser is contained uh, JPEG images, video records, MP3, MP4. So that kind of active functions is taken care by presentation layer. Session layer. If you are opening on browser and in Google Chrome, and you can open the another tab for the Facebook login, and you can open another that for Instagram login. So that time that each tab having the sessions, like it's need to communicating to the server. So that sessions is taken care by session layer. Transport layer, this is called the heart of OSI layer because this is the important layer to transmit the data from one device to another device. So it is called heart of OSI layer. Oh, network layer. Network layer is the same, like it's transmitting data to the network device. It will check the IP version for details itself. Router is having part of this network layer. Data link layer, it's checking the MAC address itself, so it's related to the switch side. And physical layer, it's converting the media to the bits to transmitting data from one device to another device. So this is the 7 layers it's we need to talk. And first 3 layers, it's called upper layer or software layer. Why? Because already I explained, like it's related to the applications where we installed in desktop, browser, mail, everything. So that is called upper layer or software layer. In bottom 3 is the lower layer or hardware layer, like it's functioning with the network devices like router, switch. So that it's lower layer and hardware layer. If any network related issues is happen, we need to check these 3 layers only. Okay, so it's already explained, like transport layer is the heart of OSI layer. So you can see the simple tips to remember the 7 layer is: a penguin said that nobody drinks Pepsi. So you can remember this sentence to easily memorize this. 7 layers names. Okay, yes application, yes presentation, SS session, DS transport, NS network, DS data link, PS physical. Okay, it's a simple tips to remember the OSI layers. Next one, the interaction between layers in the OSI model. In device A need to send the data to device B, or getting the data from the device B, it will send a byte signal to the intermediate node in this node, like a router, switch, or anything. Okay, so here you can see the 7 layers is here in the center side. This side, the receiver side, that 7 layers is available. Here you can see that application layer is communicating to the application layer peer-to-peer protocol. Like if we are using that mail server, Outlook, or anything, so that Outlook client, we are using that Outlook IM365, so that Outlook application is directly connecting to the Outlook server. So it's using some peer-to-peer protocol to the 7th layer, it will directly communicating. So next, the presentation itself also same like that only, and session layer also same. Already I explained the session layer what the function is doing. So it's directly connecting to the server, or if the data is transmitting to two devices, it's using that application itself, it's directly communicating. So then this transport layer is using two different type of protocols like DCP and UDP. So in coming up sessions we'll talk about the TCP and UDP. It's like using to some kind of port or anything to communicating the devices. Okay, in transport layer itself you can see that network layer is, and data link layer, physical layer, these three layers only is transmitting data to the another router or devices to transmitting to the end device. It will be like if we are using ISP or something in internet, it will communicating this data to multiple devices to reach the destination server. So here you can see IP version 4, IP version 6 address will be there in network layer. Data link layer only checking MAC address, it's sending frames to physical layer. Physical layer is converting the frames to bits to transmitting to the physical layers, like so it will again it will process the same like physical to data link and data link to network, and then it's network to network data link, and it will using how it will communicating these packets to network to physical, and then physical to data link, then that network to data link. So this kind of only that communication will going. Okay, so it will transmitting the data to one router. Here we can use routers or switches, whatever. It will check this data and transmitting to the destination, and it will finally it's reaching to the server. Okay, so if once this server is receiving the data, again it's transmitting the sender requesting file, it's going to this upper layer itself, and it's network layer and then physical layer. So this physical layer transmitting that byte to here as a byte, again the bytes it's converting to the frame, then packet. So it's this router is sending to this side, same that communication is happen again. Okay, and it will send the data to our destinations. Okay, this is the voice layer communications. And exchange using the OSI model. Here you can see last slide we see that how the communication is going. So here I will explain briefly, like If that layer 3 application is sending layer 7 data, sorry, layer 7 application is sending layer 7 data, so it will coming to the layer 6 session, and layer 6, that including that layer 7 data plus it's adding header 6, it's for layer 6 header, then it called it this total level L7 data plus header 6 is called L6 data. It's going to L6 data to fifth layer, and then fifth layer we can it's adding header 5, so it's called layer 5 data. Then the layer 4 itself it's adding header 4, and layer 3 itself it's adding header 3. In layer 2 it's adding trailer and then header. Two things is adding only for the layer 2 only. Okay, in layer 1 it's just converting the layer 2 data to bytes, and it's transmitting to the physical medium. Same occurred here. It will be decoupling that data from, it's removing header file from the data. So in L2 it's removing trailer and header 2, in L3 it's removing header 3, in L4 it's removing header 4, L5 it's removing header 5, L6 it's removing header 6. So the same communication will be going to this end, and if it's sending any data it will adding the header files to that once, and it will transmitting here itself. Okay, so that note is headers are added to the data at layer 6, 5, 4, 3 and 2. Okay, in trailers are usually added only at layer 2. Application layer. Application layer is responsible for providing network services to the user. It's also known as the desktop layer. Identification of services is done using port numbers. Already I told that we are simply taking for the Outlook services. Ports are entry and exit port to the layer 7. Total port is 0265535. Reserved port is 021023, and open client ports it's 10242655535. Each services having that reserved ports, it's for uh, special functions like normal. Commonly we are using major functions. That reserved ports is for reserved. I will share you some of the reserved ports. In HTTP all know, so it's 80 port only it's using. In HTTPS 8080 it's using. In FTP file transfer protocol is using 21. SMTP it's a mail server, it's mail server protocol, it's using port number 25. Telnet it will be using port number 23, and TFTP using port number 69. Okay, then next one is presentation layer. In presentation layer is responsible for converting data into a standard format. Examples as ASCII, it's like JPEG, MPEG, MP3, WAV, and then MOV, MP4, all the formats like media formats. Presentation layer is containing that media formats only, JPEG files, so that it will be encoding the media files and using encoding, decoding, encrypting, decrypting, compression and decompression. This kind of features only that presentation layer is containing. Its major concern is its translation inappropriate between different encoding systems. If the same encoding methods we need to use in both sides, and encryption also, its encryption methods using privacy schemes like encryption itself is a huge topic. We can talk in that security session itself. Compression also, data compression, so that time also we need to check. Okay, You can see this website is having multiple kind of documents, like in here that Microsoft image, that is a JPEG file, and then Word documents. Some, if any video is added in that website, means that kind of media file also, it's taken care by presentation layer. Okay, the note, the presentation layer is responsible for translation, comparison, and encryption. The same three things only. So this is the important. Yeah, the session layer is responsible for establishing and maintaining, terminating the sessions. Session ID works at session layer. Examples: remote procedure call, SQL, structured query language, network file systems. Here you can see that Yahoo image file is there. If you are using Yahoo Mail in one tab and another tab you are using YouTube, the session is taken care by session layer. This is important thing. The session layer is responsible for dialog control and synchronizations. Transport layer. Transport layer is responsible for end-to-end connectivity. It is also known as the heart of OSI layer. Following tasks performed by transport layer: identifying service, multiplexing and demultiplexing, segmenting, sequencing and reassembling, error correction, flow control, this kind of thing. Identifying service, TCP and UDP. Transport layer is using TCP and UDP protocol to establishing connection between the source and destinations. Transmission control protocol, it's a connection oriented protocol. Why? Because if it's need to transmitting data to one device to another device, it will send handshake, three-way handshake to establish the connection. So it's called slower protocol, and it's need the acknowledgement to transmitting the data from one source to destination. So it's a fully reliable, and without data loss we can send that packet from source to destination, and it's using port number 6. Example: HTTP, FTP, and SMTP. These are all using TCP protocol to communicating source to destination. Okay, in user datagram protocol, it's a connectionless protocol, and it's no need the acknowledgement to send the data. It's just send the data to broadcast whether the receiver is received the data or not. It doesn't check the receiver is receiving the data or not. It's directly transmitting data. It's like unreliable and faster. In live example, if you are checking the watching live sports game, cricket, football, it's using the user datagram protocol to transmitting the live broadcast. Okay, example is DNS, DHCP, and DFTP. Multiplexing and demultiplexing. That word itself you aware. Multiplexing means it will be the process of multiplexing divides a communication channel into several number of logical channels, allotting each one for a different message signal or a data stream to be transferred. The device that does multiplexing can be simply called as a max, while the one that reverses the process, which is demultiplexing, it's called as a demax. Okay, just it's multiplexing the communication channels with a logical channels. Segmentation, that name itself you are aware. If that sender is sending some data to the destination, the data will be segmented. Like this is the sentence, the packet sentence sending to the receiver. It will be segmented like hello, how, like that. It will be segmented and send it to the receiver. Sequencing and reassembling. While that segmentation is segmented the packet to multiple segment, in sequencing is collect the data and it's using the reassembling method to reassemble the packet and send it to the user display. Okay. Error correction. Error correction is also like the packet, it will check the whether that all packets is received and reassembled or not. Like that it will check in error condition state. In flow control, it will flow control and windowing, it's a major topic. That windowing is called how much window size that uh, end user, receiver or transmitter both is having, the need to check the window size before transmitting the data. Like examples, in this case it acknowledged received 4 window size, so this PCA can send a 4 segment at a time to the PCP. It will using to reassemble the 4 segment at a time, so it will receive the 4 windowing size. It's called windowing. Okay. How much that segment will be sending at a time to the receiver, it's called windowing. Network layer. Network layer is responsible for providing the best path for data to reach the destination. Logical addressing works on this layer. Router is a network layer device. It is divided into 2 parts. Routed protocols. Routed protocols means it's already having the routed function. We no need to change anything. It's example IP, IPX and Apple talk. That message is using the routed protocols only. In routing protocols means we need to configure the network and some configuration to the routing protocols. Below are the examples for routing protocol: drip, IGRP, OSPF, EHRP, BGP. So that kind of protocols is there. So that network data link layer is divided into 2 sub layers. Logical link control, it talks about band protocols, example PPP, HDLC, frame relay. MAC, media access control, it takes the physical address, it is a 48-bit address, 12-digit hexadecimal number. It is also responsible for error detection. Okay. Devices working on data link layer are switches and bridges and NICs, NIC cards. Okay. Physical layer. In physical layer is responsible for electrical, mechanical and procedural checks. Data will be converted into binary, example zeros and ones. Data will be in the form of electrical pulse if it is coaxial or twisted pair cable, and in the form of light if it is a fiber optical cable. Devices working at physical layer are hubs, repeaters, cables, modems, etc. Here you can see zeros and ones, the packet is sending to the receivers. It's like it's called bits. Host and media layer. In application layer, the packet is called from data. Presentation layer also it's called as data. Session layer also it's called as data. In transport layer it's called as segment. Okay. In network layer it's called packet. Data link layer it's called frame. In physical layer it's called bits. Here you can see in this diagram, data layer, here these 4 segments it's called host layers. In bottom three is called media layers. Okay, comparing OSI with TCP/IP protocol. TCP/IP protocol is the latest one currently we are using, so it will be using that OSI layer functions only, but it is somewhat different, that name itself only, but that basic function is same as OSI layer. That name is has been changed. Like if application presentation session layer, three layers is called here application layer. In transport layer is same as transport layer. In network layer it's called internet layer. In data link layer, physical layer is called as a network access layer. This is the simple difference in TCP/IP protocol, but both is using the same method to transmitting the data from one layer to another layer. Like here, this three layer is using different functions, but here this application layer using the do the all the three layer function in single layer itself. That's it, friends. Thanks for watching.